Okay, we were to an interesting series problem. We've got the series from n equals 1 to infinity of the square root of sine 1 over n. Okay, I did one really similar to this a little while back where we just had like a different exponent on the sine. What I want to do for the first step is, so what I like to do whenever I'm not 100% sure is let's do the divergence test on this to see what happens when n is approaching infinity. So we're just going to take the limit as n's approaching infinity of this whole thing here. But what you'll notice is when n's approaching infinity, 1 over n is going to be 0. Sine at 0 is 0. Square root doesn't matter, so this limit's going to be 0. So now this is actually inconclusive. We can't say that it diverges, but we also can't yet say that it converges. We don't know at this point. It's only if we got a non-zero value that then we could just say it diverges really quick. But with this case, we're going to need to do some more work on this. So what I want to do is I want something to compare this to. It's kind of with something like this, it's like not clear exactly which test we want to do. So first what I want to notice, if we had something like, I think for a comparison point, what I want to use is, what about 1 over square root of n? Because doing it this way, it looks kind of like this with the square root, sort of, I guess. But also for this square root of n, I can write this as n to the 1/2. What that's going to allow me to do is we can use our p-series test on this for something of the form, same kind of sum, 1 over n to the k. For this right here, our check is when k is greater than 1, this is going to converge. And when k is less than or equal to 1, this diverges. So in our case here with 1/2, k is going to be less than 1. So then this here we know diverges. So what I want to do on this is let's use the limit comparison test, comparing this to this. If we pass the test, we're going to have the same convergence and it's going to diverge. If it's a different convergence, if we don't pass the test, then we have to do another test. So we'll just go ahead, I'm going to set this up. So what we want is limit as n goes to infinity. Doesn't really matter what I put in the numerator or denominator because in the test, a 0 or infinity is going to fail it. So it's like if you flip it, if it was a 0, you're going to get an infinity. If it was an infinity, you're going to get a 0. So like it really doesn't matter. And then with it set up like this is where the square root comes in handy, is because we've got kind of the same thing. I mean, the 1, I can write this as a square root of 1 too, right? So another way for me to write this whole thing is let's just put the whole thing under a big square root. And then you may recognize that this thing is starting to look kind of familiar. If I can do like a substitution on this. Let's just set m equal to 1 over n. Then what's going to happen is when n is going to infinity, then our m value is going to be going to 0. So let me just drop the absolute value for a second and rewrite this. So let's look at this with the substitution. So we have m going to 0, and this becomes sine m over m. But this right here is a well-known limit. This one, when you prove it out, is usually done with the squeeze theorem. But when you do this, this is actually the same thing as 1. So if you're doing this out kind of formally, what you could do is you take the limit of this, and we know this limit is going to be 1 when we do this all out. The square root's not going to matter. The square root of 1 is 1. So the value, let's put it over here. So the value for this whole thing, this limit, is just going to be 1. And then our check for this is just that, is this a finite value and is it greater than 0? Yes, both these things are true. So this is going to pass the test. So our original problem has the same divergence as this right here. And so we can say that this right here, this also diverges. Again, if you ended up getting a 0 or infinity here, you'd have to do some other test, do some more work on it. Anyway, there you have it. Good problem today with the limit comparison test. Thanks everyone for watching. Have a good day.